Hello everyone. Vehicle prediction in Tamil similes with POS-Aware transformer models. A multi-stage fine-tuning approach for simile vehicle prediction in Tamil. A simile is a figure of speech that explicitly compares two different things by saying that one thing is like another. So it typically contains comparison expressions such as like and as. For example, consider the sentence Vairam pola kangal pirahasitana, which translates to eyes shine like a diamond. In this sentence, the diamond is the vehicle, the eyes is the tenor, and the property or context shined is given to the eyes, which is the tenor, using the vehicle Vairam. Tamil language, being a low resource language in the NLP context, currently lacks tools for simile generation. Recent advancements in large language models, particularly Tamil multilingual LLMs, present a unique opportunity to develop a simile generator through fine-tuning. Our challenges for this approach are to create a suitable Tamil simile dataset appropriate for this task and to fine-tune LLMs to generate similes effectively even with a small dataset. Our research motivation. Similes are crucial in message translation, NLP system, cross-cultural communication, and multilingual understanding. It also improves user engagement in chatbots, storytelling, and creative content generation. And this research will be the first to address simile generation in Tamil. And it will also be a foundational approach for other low resource languages. Our research objectives are first to build an unrated corpus of Tamil similes and to develop a simile surface realization for Tamil and to evaluate and benchmark the performance of our model. In the literature, we can see for simile surface realization at early times, word embedding based methods were used. And then knowledge graph based approaches were also. After the invent of pre-trained language models, we can see the current trend is to use pre-trained language models. For simile surface realization, there were some data sets which were in English and Chinese, which were manually annotated, and also in the step 3, we refined sentences to clearly identify vehicle, tenor, and context of the similes. As a result, we were able to get Tamil simile dataset containing 1520 simile sentences annotated with vehicle, tenor, and context with an inter-annotator agreement, Krippendorf's alpha 0.78. This is the first manually annotated simile dataset in a language other than English and Chinese to best of our knowledge. Our dataset comprises similes from diverse sources, capturing regional dialects, linguistic diversity, and cultural expressions unique to Tamil-speaking communities. Our short paper titled TST, Towards Computational Processing of Tamil Similes, a Tamil simile dataset published at the 5th workshop on Speech, Vision, and Language Technologies for Dravidian Languages, NAACL 2025. We used pattern-based data augmentation to increase our dataset size. We exploited the flexible word order property of Tamil language, which retains meaning even if we sub the order of the words. Using this property, we identified 3 patterns and we were able to expand our dataset. And we also used the tool Navi to correct compound formation errors and to improve the natural flow. We frame the simile vehicle prediction as a mass language modeling task. Our objective is to, given the sentence with tenor and context, predict the masked vehicle. We fine-tune models with film mask capability. We fine-tune monolingual model, Tamil BERT, and multilingual models such as Indic BERT, Mural, XLM Roberta. Top 10 predictions were obtained from the model's masked word prediction hits. We employed a multi-stage fine-tuning strategy. In the stage 1, we fine-tuned using a large corpus of created Tamil texts and adapted the model for the domain. And in the stage 2, we did task-specific fine-tuning for vehicle prediction, where we fine-tuned the domain-adapted model on an augmented TST for the vehicle prediction task. Initially, we took the base model and fine-tuned using the Tamil simile dataset and augmented dataset to get the single-stage fine-tuning model. And in our 2-stage fine-tuning approach, base model was fine-tuned on large Tamil corpus and corpus-tuned model was got, and then we fine-tuned the model using our Tamil simile dataset with augmented dataset to get the 2-stage fine-tuning model. Then, to improve the performance further, we employed POS embeddings to the model, and we got 2-stage fine-tuning model plus POS embeddings. Parts of speech tags identify grammatical roles of words such as nouns, verbs, and adjectives. We use Tamil POST to get the POS tags for the sentences, and we added POS text as an embedding layer with the embeddings present in the bird. Incorporating the POS text as the bird tokenizer create the labels and masked, we parallelly use the POS tag to get the text of the sentences, and we align the POS text and map the POS text to IDs and input them as input for the model. We experimented with different approaches, and the gated method to add the POS embedding method embeddings to the token segment positional embeddings to the bird layer in a gated way, where the gate decides how much of token embedding and how much of gated projection will be allowed to go into the model, gave us the best results. In the inference phase, we input the sentence and we tokenize it, while the other side, we get the POS text of the sentences and we align the POS text and also map them to the ID, and we also give the mask the POS text noun to get the noun words as the predicted vehicles. And we will get the predicted tokens for the mask. And we used exact match evaluation, where we get the answers as correct if the predictions exactly match with the correct answers, and synonym based evaluations, where we incorporate synonyms of vehicles into the data set and take those also as correct if the predictions were synonyms of the correct answers. And we used both automatic and human evaluation matrices. As automatic evaluation matrices, we used mean rank, mean reciprocal rank, and hit set n, where we reported hit set 1 and hit set 10. For human evaluation, we reported precision at 5, which measures the precision of the top 5 predictions in relation to the correct answers. We also compared our best performing model with GPT-4o and GPT-4 in a zero-shot setting to perform the same vehicle prediction task. Automatic and human evaluations are performed and compared with our best performing model. For human evaluations, 3 native Tamil-speaking evaluators were used, and a new test set with 20 simile sentences was used. Evaluators were shown the top 5 predicted vehicles from our model variants: base, single-stage fine-tuning, two-stage fine-tuning, two-stage fine-tuning plus POS from the best performing model and the GPT-based models. Evaluators judged a prediction as correct only if it was semantically meaningful, fit naturally within the sentence context, and resulted in a coherent and valid simile. Experiments and results. As you can see in this image, initially the base model predicted words which are frequently occurring in the sentences. And after the single-stage fine-tuning also, we were not able to improve much. In the two-stage fine-tuning approach, we were able to get better results, and with the POS embeddings, we were able to get even more better results, as you can see in this image. The automatic evaluation results show Tamil Bird performing better than the multilingual models and XLMR model, which performed very low. When we compare our best performing model Tamil Bird with GPT-4o and GPT-4, our best performing model outperformed GPT-4o and GPT-4 in zero-shot settings. In hit set 10 metrics, we can see it got 0.69 with synonym evaluation and 0.49 with direct match evaluation. And our human evaluation metrics also validated our results from automatic evaluation, where our two-stage fine-tuning plus POS model outperformed GPT-4o and GPT-4, which basically performed around equal to our single-stage fine-tuning model. Project deliverables and applications. To make our research accessible and useful, we developed 2 web-based applications. Our goal is to empower writers, poets, and students and language enthusiasts with AI-powered creative tools for Tamil language. These deliverables are powered by our best-performing Tamil Bird two-stage fine-tuning plus POS model. Uvami, the Tamil simile generator. In this application, the user can give a model with mask inputted in place for the vehicle, and they can generate similes for that mask. And they can also give target and the context, and they can choose one of the 3 templates we used, and they can use the template to generate possible similes. You can access the application in this following link. We also build Tamil Creative Writing Assistant, where users can write sentences where they can input masks to predict the suitable vehicles, and also our model suggests places to input suitable similes and also suggest different similes suitable for the sentences. Tamil Creative Writing Assistant can be accessed through this link. Thank you.